Hi guys, welcome to this video on triangle similarity. Triangle similarity, we're going to learn to determine if two triangles are similar using a scale factor. Similar triangles are used in construction and engineering to make educated estimates. And then you can calculate the ratio between triangles that are similar. That's how you know you're going to be doing this correctly. So what is triangle similarity? Two triangles are considered similar if they have two congruent angles and a scale factor exists between them. All congruent angles. Uh, you can use two angles, angle, any two, or two out of three of them are marked. If you know all of that information or any of that information, the triangle angle sum theorem kicks in and means that all of the angles are congruent. If two out of three are congruent for both pairs, then the last one must also be congruent. Remember that the corresponding pairs of sides are the ones that are in the same positions on the triangles. And similarity can be written in a triangle as saying triangle blank 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 would be similar to, it's the tilde symbol, triangle blank blank blank. The tilde would be the top half of the congruent sign. Triangles that are similar have a scale factor. If all of the angles of the triangle are congruent, then you can look to see if the sides are proportional. That is, they have a constant ratio between all of the corresponding sides. So, one of the triangle sides from one of the triangles divided by the side of the side length of the other must be equal to the side length of the first triangle divided by the side length of the second, equal to a third side of the original triangle divided by the third side of the second triangle. They must all be in the same ratio. So using scale factors. Once we find scale factors, we can use it to establish the lengths of missing corresponding sides of those similar triangles, and then you can do this using proportions, math's magical tool. Side pair 1, so a missing side of one of the triangles, divided by the corresponding side of the other, must be equal to another side of the original triangle divided by another side of the other triangle. Then you can solve for x by cross multiplying and dividing. So determine if the triangles are similar below. If they are, what is the scale factor between them? So 1 and 2 angles are already marked as congruent. So that means that all the angles are congruent, and that's angle. All right, 2 out of 3 are congruent. It means the third is congruent by the triangle angle sum theorem. So since that's true, I can just check the sides. So let's pair up the sides. So 4 and 8 are corresponding, 6 and 12 are corresponding, and 14 and 7 are corresponding. So if I do 8 divided by 4, I get 2. If I do 12 divided by 6, I also get 2. And if I do 14 divided by 7, I also get 2. And that means, since all of the sides when divided are equal to the same number, that means the triangles are similar. So I can write that triangle A, B, C is similar to triangle P, Q, R. So determine if the triangles below are similar, and if they are, determine the scale factor. So 2 out of the 3 pairs of angles are already marked as congruent. So using angle, I can say that all of the angles are congruent. That is proven. So now I just have to check to see if the sides are proportional. So 10 and 3, 16 and 4, and then 2 and 8. So if we do 8 divided by 2, I get 4. If I do 16 divided by 4, I also get 4. But if I do 10 divided by 3, I get 3.3 repeating. And so 2 of these match up, but this third one does not. So I can say, I have to conclude here, that the two triangles triangles are not similar. So in the two triangles below, determine the measures for S and T if the triangles are similar. So I can say for certain that all the angles are congruent. So I have a 90 degree and a 90 degree here, angle C and angle T, and then angle B and angle S are marked as congruent. So through the property of angle, I can say that all the angles, fix my A here, all angles are congruent. Okay. And then I need to pair up the sides. So 5 and T look like they're the same. 3 and 9. And 4 and S. So it looks like since 3 and 9 are the only numbers that I have on both pairs, I'm going to use them as my anchor pair. So I'm going to write a proportion. So 9 over 3, since those are my anchor pair, must equal, let's do T first, 5 divided by T. So I'm going to cross multiply here, and I get 9T equals 45, or 15. Oh, I didn't pair, you know what guys, I made a mistake. I didn't pair up my, and this is where you got to be careful, I didn't pair them up correctly. The 5 should be on the bottom, and the T should be here. Because T and 9 are in the same triangle, and so are 3 and 5. So good thing I caught that, or my problem would be wrong. So 9 times 5 is 45, and 45 would be equal to 3 times T. So if I divide both sides by 3, I get that T is equal to 15. So it's 15. And then I can do the same thing for S using the same anchor pair. So 9 over 3. And then this time I'm keeping it, make sure I keep it correct. S over 4. Since 4 and S correspond, and 3 and 9 correspond. So I get 36 equals 3S, and divide both sides by 3. So S equals 12. And we did it. So, using the properties of similar triangles, determine the value of fx in the diagram. So, I have two similar triangles, and I know that they are, for now, based on that these angles are congruent, they're marked as such, and they correspond. These angles are congruent, they're marked as such, and they correspond. And then this one here overlaps itself, so reflexive property says that it is also congruent. So I have a small triangle, so triangle CVE. So I have triangle CVE, similar to triangle VTF. Technically, the F comes first. So side CV is actually 10 in the small triangle, but side FV is actually 16. So it's 10 over 16, because I am searching for this missing length here. In order to find this missing length here, I'm going to need this one in here. So 10 over 16, so the 10 is this side, CV. So I use side CV over FV. So now that has to be equal to, we're going to use side TV down here, 15. So TV from the bigger triangle is equal to side Y here. We don't know. Missing side EV of the small triangle. So I have enough to cross multiply and solve. So 10 times 15 is 150 equals 16y. Okay, so then what I am going to do is I am going to divide both sides of my proportion by 16. So 150 divided by 60 gives me 9.375, and it's okay to get decimals, must be equal to y. So that value goes here. And then I can, in order to find x, I'm going to take 15 and subtract. So I'm going to take 15 minus 9.375. And that's going to give me 5.625. And that's what has to equal x. So x has to equal 5.625. So in summary, guys, for similar triangles, you want to establish the angles are congruent first. Then you want to establish a scale factor, and then use a proportion to find missing sides. So that's it for today's lesson on similar triangles. And thanks for watching, guys. We'll see you in the next one.